So thanks to everyone for joining this session, and thanks for giving me this opportunity to discuss or share with all of you my perspective about the sustainability challenges and considerations which can be applicable for generative AI. I'm Sourav Mazumder. I am a distinguished engineer in IBM, and my focus area is AI solutions and sustainability. So today in this talk, I will primarily focus on the high-level aspect of the thing because I really don't know what is the level of everybody's understanding about generative AI. But please feel free to ask me any questions at any detail or depth. So please feel free to ask me questions, and let's make it more dialogue-based interactive session. So with that, I would start my presentation mode. Okay. So generative AI. So as so many people already here in the session, I am very sure all of us here, we really believe in generative AI, that it is going to create a big thing in the industry. And as we are seeing from these numbers, by 2032, it is supposed to become close to 200 billion. So all of us know we can contribute to this big thing. And obviously, whether you are a user company like an organization who wants to use generative AI, or a company like us, IBM or Microsoft, who wants to provide solutions and technology around generative AI, I mean, for everybody, it's a big opportunity. But as we see that the generative AI also comes with challenges in terms of its impact on environment, impact on the overall sustainability of this earth. So as you are seeing here, this is from an article which is as latest as this September 23, where in the press conference, Microsoft is saying that yes, our generative AI models, they are essentially energy hungry, and they create quite a bit of carbon footprint on the environment. Now, it is not just about the energy consumption part of it, right? These technologies also guzzles lots of water, because all the big infrastructure where these models are running, these models are trained, they also need to be, the temperature has to be maintained, right? So there's a lot of water is needed also to maintain the temperature of this infrastructure. Now, before getting into the detail about why it is and all these things, why it is so-called have so much of impact on sustainability or environment, let us take a step back and see what is this generative AI about. Now, we all know about AI, that it is nothing new. It has started probably back in 1950s when the Turing machine was invented, right? But what happened so far, even till as latest as 2017, 2016, all these AI models were essentially supervised models. That means somebody has to provide a training data set with examples as well as results. So labeled training data. And all the models were as good as those labeled training data. Now, obviously, for an organization scenario, for certain use cases, it is not always easy to get so many labeled data. And that was quite a bit of, I will say, that factor which was progressing the use of AI at the business level, at the enterprise level. Like I myself involved into this data and AI journey for almost last more than 16 years or 15 years. And that is one of the problems we always found with the clients. And I mostly work with various enterprises. So that is one of the problems we always found, that even though an organization is that we are all okay to try out this new technology, new AI-based things, but where is the data? How can I make them label, like manually go and annotate them? So the generative AI is essentially solving that problem. So generative AI, here the models are essentially semi-supervised models, which needs a very less amount of labeled data. And they are all based on these concepts of foundation models. So let us see what are these foundation models are. So in the traditional AI models, we know that we have different data. We train individual models which are fit for purpose for a particular use case or particular questions to be answered. And that's the way things work. Whereas in the generative AI case, we are talking about a foundation model, which is just like a software foundation architecture or foundation layer. So here you actually provide lots of data first to create the foundation model. And once that foundation model is created, that it is typically created once or even written at a very less frequency, then you can use this foundation model for various kind of tasks by by adapting it, or through adaptation, or through tuning, as we say, by providing some amount of labeled data. So this entire thing is so much game changer that it not only reduces the need of the actual labeled data, but also it helps to build the task-specific model at a much, much lesser time. So there are different type of foundation models which can help in different kind of AI-based tasks. First thing, what all of us are probably very, very familiar with here is the text models or language-based models, large language-based models. We know there are so many chatbots, ChatGPT, and all these things are happening in the world. And it is used right now for so many things, right? For creating a content, a new type of summarization, or creating some kind of new generation, say, a marketing statement or some advertisement. So everywhere today, I believe the large language models are used in some form or fashion. But along with that, there could be other time series models, other foundation models also. The next example, which is pretty close to my heart, is the time series model, where essentially, given the data, we are trying to model a continuum of events which are happening over the time domain. So if we have that volume of data, and if we can use the similar principles of transformer, which is used for language model, then essentially we can also have a time series model. And it can be used for so many purposes. Like in IBM Atlas, we are trying to use it for the order prediction, for predicting the anomalous behavior, the faults of big machines, by getting all the machine-related information in this time series model, the events, the past events. Then the image models, image foundation models, say you take a particular type of material and you create a foundation model for that particular material, then it becomes so easy to detect the anomaly when that material, say, used for a particular purpose. Say maybe that material is used for building various kind of cars. Now, instead of trying to take example of the failure or anomaly for each and every car, if we have a foundation model for that particular material, then we know that if any kind of new data is coming, we know that whether it is a anomalous behavior or not. Then code generation model, probably you people have seen that few days back, IBM released a model for changing or essentially migration of code from, say, COBOL to Java. A geospatial model, where all the location-based information are put together in a foundation model, so that based on that, you can actually predict various kind of things, the scar on the particular surface, the water body, the biomass, those kind of things. Then speech models, and I'm very sure many more to come. So one thing is very clear, that in this game of this generative AI, this foundation model is all about creating a huge huge, a model with a huge volume of data set. But the point is, it is not just about the energy consumed during the creation of the model. It's also about how you use the model during that point of time. So before getting into that detail, let us do a simple experiment. So let us ask generative AI itself to what is its energy footprint. Now, for that, I will actually quickly go to live interface. All of you are able to see a live interface, what I'm showing here?
Yes.
Okay, I'm taking...
We see it. That's
okay,
good.
Perfect. Perfect. So here I'm essentially using a prompt lab. This is from IBM, and it's a kind of a free tool available in the cloud. Anybody can use it. And as you all are seeing, probably the question I'm asking to a generative model, a large language model, that, hey, how much carbon dioxide equivalent can be emitted by a single large language model? And we'll just do a little bit of fun experiment with this. I will use a different kind of large language model. So first I will use a GPT model and ask that guy the question that, hey, and it is actually telling me a lot of stuff. Okay, it is actually almost telling me that 12 hours per day for 4 years at its state are the results, and this would mean that roughly 3 tons worth of carbon dioxide emission every month. Okay, so now let me go to another model, the Llama from Facebook, and see what Llama says. So it is almost giving me a full description of what all can happen. Perfect. And I think that this part is the most interesting one, right? Which says that to put this into perspective, 27 million metric tons of carbon dioxide equivalent is roughly the same as annual greenhouse gas emission from 55,000 cars driven for 1 year. And it looks like that is the equivalent of a use of a large language model in 1 year. So that's what Llama is saying. Now let me go to the foundation model from IBM, which is equivalent to Llama or ChatGPT. And let me see what it says. Okay, now I have to first remove this. So let me go there and see what this says. Oh, it tells me a very simple cryptic answer. It tells that ChatGPT emits an average of 22 grams of CO2 per inference request. So one inference in this case, that as soon as I press the button here, generates, so that is one inference. So for each one inference, it is actually generating 22 grams of carbon dioxide. So this is a good, fun experiment, and it essentially shows the reality by using the tool. But let me go back to what is the overall industry perspective on this. So this is a chart I really like, and you all can get it from the towards data science in the Medium. It very, very clearly shows that where essentially the energy consumption happens for the large language models or generative models, it is at the model deployment or the inferencing time, where everybody is putting that generate button either through API or UI. And this is something very interesting because, it is kind of obvious that when we are talking about generative AI, we are talking about foundation model that, okay, you build the model once, but then you use it so many times so that you really don't need to build a small model. So this is kind of obvious, but the difference what we see is that is really mind-boggling. There is another example I just quoted here. This is for the some research paper from Bloom, who actually did some analysis on the Bloom model of Google, and it is also talking about something very, very similar, as they found that on average, it can actually consume 1.6 kilowatt hour every second of energy. So this inference part, the generation part, using the large language model or generative AI part is really, really huge. So rest of the part of my talk, I will primarily try to focus on that area to see how we can still optimize it. Now, before going to that, let us get into the little bit of further details of how that adaptation of foundation models happen for different kind of use cases. So the first and pretty much the early type of adaptation was that, okay, I have a foundation model, and then I do a tuning of that model for one particular use cases. So the model is still at the pre-trained level. I put lots of input text, and it essentially distills the model. I think distill is not the very right word. It essentially creates a new model which is just focused on that particular task. So what we call this typically as fine-tuning, model fine-tuning. And then there is another end where we call it as a prompt design or prompt engineering, where the pre-trained model is frozen, the foundation model is frozen. It will not be further touched. Now, what is happening? I'm just creating different kind of prompt or prompt templates to use the model in an intelligent way. So at this stage, since the model is not changing, I am using that big model to get my task done. Whereas in this case, the model has been further tuned to a very small size comparatively, and that new model is the fine-tuned model is used for the task, for answering the questions. And then there is a midway, what we call prompt tuning. And prompt tuning can be for a single task or multiple tasks. So from IBM side, we have a research on how you can actually tune a model for multiple tasks by providing some examples. So here what happens is there are tunable soft prompts, means examples are provided, which essentially working or not working, it gets added to the already frozen model. So this one is kind of midway between the pre-trained fine-tuning and the prompt engineering, and it does not change the model, but it adds some extra parameters to the model. So for the fine-tuning model, the weight, the parameters of the model itself gets changed. For the prompt design part, nothing changes. The model is remaining as is. In the prompt tuning part, actual model remains as is, but we also add some extra parameters, some extra weights and biases to specify, to make the model work for specific tasks. And generally speaking, again, the term general is important, that the usage time, energy consumption essentially increases from the left to right. Now, knowing this, let us see how these things are actually can be used in a usage context of a big organization. And I will show you two kinds of deployments. One is in cloud, another is on the on-prem side. So there would be the people would be using these various kinds of use cases on generative UI, or there would be applications which would be using UI or API. And typically 4 patterns we see. One is very ad hoc way of using foundation model when there are some data scientists, they're coming and they just want to figure out how the foundation model is working, putting some arbitrary text, arbitrary questions, arbitrary instructions. So, but that is important, right? In an enterprise context, there is always a need for that kind of ad hoc understanding. But then one can make it a little better by creating a bunch of prompt templates so that the person who is trying to explore the foundation model need not do it in a completely haphazard way. One can create a bunch of engineered templates so that they only interact through the templates. And then comes the prompt-tuned models. I'm just talking here about LLMs, but it can be applied for any kind of generative UI, where we have used either single task prompt tuning or multiple task prompt tuning, and then the end users or applications interact with that particular model. And then finally, the fine-tuned models, and it is used directly by the use cases. And in this particular deployment option, say the enterprise side or the organization at the client side, whereas the server side is basically, say they are using the models, foundation models from say IBM or say from OpenAI, Microsoft or Google. So it's a typical approach which is pretty prevalent these days because not every organization wants to spend money in building the foundation models. So this is I will say one kind of representative architecture of the deployment. Now the question would be that, okay, so in that case, the organization are primarily responsible or should be worried about the energy which is consumed at this site, because other side is more at the vendor level who are providing the models. But no, that's not really the case, especially from the purpose of the reporting, from the purpose of a net zero goal of any organization. So this part is what we call scope 2 emission, because here the organization is actually spending that much of energy, but they are also responsible for the scope 3 emission, where they are buying some service or some product, yes, a foundation model service from other vendor, but the organization who is buying that service from the vendor is also responsible for that under the head of scope 3 emission. So essentially, when we are talking about sustainability, it is not just about just saying that I'm not doing this thing. It is about the entire ecosystem. How I am contributing, I as an organization or even an individual contributing to the energy footprint, carbon footprint of the entire ecosystem. So that is the reason both the things are very important for any organization before they use a generative AI.
Sourav,
now, this is what.
Sure. Sourav, I have a question, maybe a dumb question, but so you said that fine-tuned models, fine-tuned LLMs can be fine-tuned for one particular use case and not multiple use cases. So for instance, it could be fine-tuned for HR, but it can't be, further fine-tuned also for, let's say, accounting. Does prompt-tuned LLMs allow for multiple use cases?
Actually, both allows for multiple use cases, but the way they allow it little different. Say, if I take for HR and the accounting, the examples you gave, for the fine-tuned models, LLM, or maybe any other generative AI model, you'd be creating a HR-specific fine-tuned LLM, say HR LLM, and you'd be again creating another one, which is accounting-specific fine-tuned LLM.
Yep.
So as you see, in that way, your training time energy consumption will go up and up if you try to create many such fine-tuned LLMs, because and also not just training time. The more you create this type of fine-tuned LLMs, you also need to deploy them, right? You need to host them in some environment. And many a times, you even don't know whether, say, you'd be hosting it in some, say, N GPUs with 100 chips and all, but maybe it is not even fully utilized, but the GPU is burning, right? They're running, right?
Right.
Whereas, so what happens in the fine-tuned LLM, your language model surely, the size of the model come down pretty much because you are changing the actual weight of the foundation model, right? So that way it is surely better. Now, if I compare that with the prompt-tuned LLM, this foundation model weights and bias, those remain intact. What happens is, along with the existing one, you add some extra. You add some extra things in their main parameter vector by providing the exactly. So this is essentially, that is the reason, easy to maintain because your main foundation model remains the same. You are not changing it. That is deployed one time. You are just having some extra layer on top of that.
Got it. Thank you.
Okay. So now let me go back to the second option of the deployment, which is all enterprise network within the same enterprise. So what is happening is, and that's, we are already hearing this kind of requirement from many of our big customers, that big customers who have money, who have resources, and who really, really care about their data, who really care about the, say, proper use, ethical use, rightful use of these foundation models, generative AI, they are saying that hey, no IBM, no Microsoft, we are not going to use your foundation model. You give me the technology, I will deploy that technology in my infrastructure and I will build my own foundation model. And that's a fair ask. I mean, if they can do that, if they're ready to do that, given the security, ethics, all those various stuff. But the main patterns remain the same, right? I mean, nothing changes. It's just that they're hosting it in their environment. And that is the reason you will see here, both the sides become scope 2. So in this kind of deployment, the organization is also directly responsible for the energy consumption by training the foundation model and the use of the foundation model. Now, given these two particular, we have around 1 hour, right?
Yes, that is correct.
Okay, perfect. I have at least 25 more minutes. So, given these two type of deployment options, and also the fact that this second one is also becoming pretty prevalent, at least for the big organizations, and big organizations also have big responsibilities towards the ecosystem, towards the art, towards the society. What I kind of did is I kind of put the considerations, the sustainability considerations for generative AI inferencing under just two buckets. One is server side, another is the client side. So at the server side, whether you are actually deploying the foundation model in your own infrastructure or you are getting the service from other vendors, few things always need to keep in mind. First and foremost thing is that, can you compress the model with acceptable compromise of accuracy? And there are various kind of mechanisms available for that. Quantization, which is essentially about, so all these large language models are about various kind of weights. And many a times those weights essentially, not many a times, I think most of the time, these weights are essentially numbers with lot of decimals, right? And whenever you have weights with the integer plus decimal in that way, it essentially takes more number of bytes. At the GPU level also, it needs more GPU for computation. And that's the reason it actually takes so much of energy. What quantization helps is essentially moving those decimals to the relevant integers. So if our weight is 20.345, it will just make it 20. Or if a weight is 20.875, it may make it 21. Now, obviously, there is the compromise for that on the accuracy, but many a times maybe some of your use cases would be pretty good with that. You really don't need to see. But the point is not all models are, they lend easily to the quantization. So that is the reason, even if you may be using a model from the vendor, you need to ask this question, need to figure it out. Hey, okay, whether this particular model you are giving me, whether you are making it quantization ready, whether you are applying that principle or not. Next comes the pruning. Pruning is nothing but removing the weights which are having very insignificant impact on the final result. I mean, there are so many 70 billion parameters or 170 billion parameters. There are always in that 20% parameters which have actually very less impact on your generation. So the pruning technology that way also can help in reducing the energy consumption of the model. Then comes the distillation. Distillation is pretty much, I mean, at the end effect-wise, it is similar to fine-tuned model, but the way you distill the model for a particular task is little different. You use some few short prompts to figure out where is the essence of the information, and then you take that particular part of the model and put it for deployment. So that is this clear pretty much industry practice these days. Most of the organizations are deploying the model in this way. But few new things are also coming on where the models are optimized through different ways, like using the key value cache. Then group query attention, where instead of putting the query one by one, a group query is sent to the model for the answer. Long document transformer, instead of each word-based attention, if a sequence can be used for the attention. So these are the very interesting technologies coming. I was just saying few days back, there is a new foundation model has come. I forgot the name of that, something like a 7 billion. And they say that they are using this technology and they are actually much less in the number of parameters, 7 billion compared to 170 billion. And they actually can do better generation compared to Llama or GPT. Then the third one is being able to create a modular foundation models. So far, whatever the foundation models we see, those are like, a big cauldron where you put a lot of data and finally some concoction is ready, right? It is not like you are creating that that final food by using different kind of purchase small building blocks, but rather you do it all at once. But this modular foundation models technology, primarily even from IBM side, we are doing this research that how brain figures out the things. So using that similar concept or similar pattern, we call it as a neuro-inspired modular foundation model. Our brain figures out the things a very modular way, and there are some foundation models are being developed in the industry as we speak, which follows that, and that will automatically become much less energy hungry because of the modularity. And the last one, but probably the most important one in the current scenario, is the benchmarking. Whether you are on-prem deploying the foundation model server or you are using from your vendor, knowing the benchmark that what is the utilization per token wise, or hyperparameter-wise or type of adaptation-wise. Knowing that information essentially helps to overall use the system. And then the other side I have at the high level is what all can be done at the client side. First and foremost is selecting the right LLM for a use case. We know, and again, I'm talking here about LLM, but it's applicable for all kinds of generative AI. That generally the transformer pattern, it has two types of things. One is the encoder decoder, another is more just a decoder base. So encoder, where you always take consideration of the entire context, whereas the decoder is all about, okay, what happened last, and based on that, I'll say what happens next. Now, all these type of things, and along with various kind of hyperparameters or the optimization mechanism used, these are very important aspects to be aware of while using a LLM for a particular use case. Like when you are doing a summarization, encoder decoder based model may be useful, whereas for a Q&A, just maybe decoder based model is useful. Then the selecting the right adaptation technology, whether you would be doing prompt engineering versus prompt tuning versus fine tuning. And then comes the monitoring. Once you know the benchmark of each model, then how you map that model level benchmark to your use case level benchmark and keep on monitoring in a regular level. And when all these things are done, you can also think of a various type of client side optimization, starting from caching, deflection, some kind of rules to ensure that your overall energy usage is under control. I will have only one more slide before I move to the for any other open questions. Now, how you put together all these things? So the thing what we have seen is that the AI governance framework, what maybe most of the other companies use from IBM side also, we have the framework. They essentially can be used not only to figure out how truthful the model is, whether there is any whether there is an ethical issue, but the same thing can be used to also for the sustainability related concerns. And some of the things what we have in our tool, and I'm very sure it can be used in other places also, is we essentially talk about these 4 building blocks of governance, life cycle governance, collecting the model facts and evidences, then validating the model after the model is developed or adaptation is done, and then ongoing monitoring. And what we essentially say that first, an organization should onboard a generative model or foundation model with all applicable checks and balances. And one of the things to check there itself is that, hey, what is your GPU characteristics? What is the benchmark there? What kind of optimization technique you are using for deploying it? And again, it can be on-premise or cloud. It does not matter. In both the cases, this is important. So first, figure out that whether you are enabling your organization for use of the right foundation model. Next comes the adaptation, and during adaptation time, while executing various prompts or prompt tuning or the fine tuning, they also capture the utilization of the GPU, capture the utilization of energy, all that kind of stuff. And once the adaptation is done, you are going for the validation. So most of the AI models typically go for some independent validation, where the scalability testing is a very typical practice. Now, at that point of time, again, you figure out how the GPU scaling happens. And once the validation is done and model is then deployed, you need to know the expected workload and the deployment environment, and then keep on monitoring the utilization, which overall closes the loop. And this framework can be used to continuously monitor the energy footprint of any generative AI model. So with that, I will I'm done with the overall talk, what I wanted to share with you all. I'm open for any questions you have.
Sourav, this is Ravi from Reliance Geo. Are you able to hear me?
Hi, Ravi. Yes,
Hey.
I'm able to. Hi.
Hey, I was like, it's a very interesting talk, and I was just going through. Sorry, I joined a little late, but I was just curious to know, in terms of optimizing generative AI inferences, you have shown 4 different ways how the industry is doing it, especially in terms of enterprise services. Where do you see in terms of one is the carbon footprint and power consumptions and others, as well as the cost? Both of them, sometimes they may be a part of the same package, sometimes they may be opposite to each other. Where do you see the enterprise industry is landing somewhere which is most optimal in terms of cost as well as carbon footprints and power consumptions?
So, in my understanding, whatever I'm seeing in last 6 months to maybe 1 year, there is no pattern has emerged so far. What we have seen mostly right now for majority of the company who wants to use generative models, they are following this path where they kind of want to trying to push the carbon footprint part at the vendor side without even probably realizing that they are still responsible for that. And obviously, when you run it or use a cloud-based service, obviously you get the benefit of scale, right? Like when say IBM deploy our foundation models, actually we support other open source foundation models also. We essentially do the deployment in such a way that it is cost-wise, it is effective. So majority of the companies are right now doing that. And then some of the companies, they want to go all out and establish their own generative AI deployment. And because of that, from IBM side also, we are releasing that pretty soon in this November itself. And here, the main questions, what at least I'm hearing from some of the very big clients is that their first order of business that how do I monitor my usage of the model? So, I mean, short answer is there is no specific pattern emerge on which I can say best practice or leading practice, but surely the monitoring is the first thing is needed, which can only tell everybody that, okay, what is your cost, what is your carbon footprint, and where is the sweet spot. By the way, I mean, in my mind, carbon footprint will, reduction of carbon footprint will also automatically mean reduction of cost.
Exactly, but I'll tell you, like the way scaling is done nowadays in the industry, I'm sure like you guys are more exposed to that the way we are seeing also in the telco world. Artificial intelligence automation at the governance side comes later. First, the infrastructure pieces and the cost is seen. That is always a prime, especially at a telco edge or like your or one layer high. Yes, at the time of data center, regional data centers and all, where you have a big racks full of GPUs and all, where you do a lot of kind of processing in terms of artificial intelligence and machine learning in the terms of different models and all. Those things goes there. I think all the analysis what you have done, are they just based on a centralized data center based AI, ML based kind of analysis, or you see that it is also done in terms of a fully distributed network where just like telco networks as well as the IT?
these analysts of this data mostly kind of, agnostic of that kind of deployment. Essentially, this analysis, what it does is that think of any generative AI, basically utilization of any generative AI inference is kind of proportional to the number of tokens, right?
Right.
And I'm only talking about the inference part. I'm not talking about the training part. So depending on what kind of use case you are using, and let me take an example of LLM use cases like question and answer versus context grounded question and answer versus summarization, or generic, just generate some component like generate a marketing component content, or say entity extraction. These are all based on the number of token you are using. And this, once you are able to connect the utilization of GPU with respect to the token, then you just multiply it with the TDU and PEU, that total, I believe the overall energy distribution and the effectiveness. And using those factors, whatever number you are saying, those numbers are calculated. So kind of they are agnostic of where are you deploying it. But obviously when you are deploying it in a centralized place, there would be the scale of economy. But again, there are so many other open areas today at the technology level, like having two foundation models deployed in one GPU is still a little bit of challenging proposition. Or say you want to deploy a model in a containerized environment so that you can easily scale in, scale out, or swap the GPU. Those technologies are there, but yet not proven. So I will say this is still pretty much in the infancy.
Thanks a lot for your answers, Sourav. Thanks a lot.
Sourav, and it's John. Everybody hearing me okay?
Hi, John.
Okay, so I'm taking my name changed on that bloody thing.
Yeah.
I'll get that another time. Sorry about that. Sorry about that. So we're going to having other conversations, I know, with Enterprise Neurosystem, from the other day or whatever. So this is separate from that. How massively parallel from a memory perspective there's a lot of complexity here, right? From a classical training perspective, let's say, for example, in genomics, sequencing expands memory quadratically. In these kinds of things, what's the extension of memory? This is maybe an offline conversation. We do these memory virtualization scale. How massively parallelizable is this so that you can fully use the memory that you have across all the GPUs, all the servers? Is there any generalization of your experience for this? And this may be an offline conversation to be far more specific.
So far, whatever we are saying, honestly, we try to put one foundation model in one GPU. That distributed paradigm, what you are thinking of, it is still very difficult to implement in a distributed memory scenario because it all depends on the logic.
So if you could, for one model, let's just say, I mean, this has to do with the staging and destaging of memory from the host system to the GPUs. But let's imagine that you could have arbitrarily scaled memory to any GPU. How valuable would that be? Now you would be going on and off.
That would be very valuable.
Okay, we should have another conversation because offline we should have another conversation about this.
All generative AI is essentially the memory play. The more you have the memory available and you can actually do the vector calculation, vector math on all those things in parallel, the faster would be your
so on the training side, right, where you're going to be building things, do you have on these big LLMs, I know some other areas of this, but not the LLMs, do you have struggles determining how much memory you want to allocate to the system as you're training scale wide on that? Does the memory go up and down arbitrarily across the compute infrastructure, or is it predictable and modular across that during the training phases?
It is kind of predictable because all these things are based on the attention architecture where it is about a single thing. And that is the reason it is very, very parallelizable. You can make it parallel at the training time. But it still consumes a lot of energy, but you can still achieve parallelism much at bigger scale compared to the inferencing time. Because inferencing time is all about searching first that where exactly the information is. And there also though the parallelism happens because you can have multiple attention working in parallel, but slowly it has to converge, right, at one point of time.
But let's imagine, I'm trying to understand this and see if there's a contribution to be made, not trying to push any kind of perspective on this. But let's imagine you had, n-way compute, and you could reduce from a sustainability perspective, you could reduce the amount of obligation for memory on any node to a much smaller number because you could donate memory to it in real time. Do you have any way to estimate kind of sustainability impact on something like that? Would that be useful, not useful?
Oh,
does that make sense?
Very useful.
Okay.
Absolutely useful.
Okay, we have other conversations. I don't want to preoccupy. There's a lot to discuss offline. People who know what we do. I don't want to occupy because there could be other questions. Yeah. This was just to validate. Should we have a chat? Okay. Yes, we should. So we'll take offline. Okay, that sounds great. Handing it back to other people. I can keep going. I just am trying not to preoccupy because this goes all kinds of places. But I want to open it up to other people.
Yeah. Any other questions?
I've shut everybody down. Sorry about that.
No problem. We also are coming close to the time. So if there are no questions, maybe we can thank Sourav and close the call.
Yeah, and Sourav, I'll reach out to you separately about this because I think there's a conversation.
Absolutely.
Okay.
Thank you, Sourav. Thanks so much for the talk, and thank you everyone for attending. We'll see you at the next ENG webinar. Bye now.
Super interesting.
Bye. That's super interesting. Thanks, Sourav.
Thanks, everyone.
Good.